In this video we can see how our IT system works. We use our PC to simulate all elements. In particular, from left to right, there are statistic unit, weather system and simulated node, the central unit, the screen of the broker and Raspberry.
This is Raspberry. It is used like a broker and node. The node have three sensors linked: temperature, humidity and ultrasonic sensor. We can see a broker publication to external provider to communicate his IP and the subscription node to the external provider. In this way, the node gets the IP of the system broker and it links to the system. We can see the first two scripts on the central unit. First publishes his IP to the external broker, and the second one is the subscription to the external broker to receive the system broker IP.
We can show in this video the statistic web service that receives the IP of the central unit from the external broker and save it on a JSON file, and then it receives the IP of the broker for the subscription of the system.
The weather system subscribes the broker IP on an external provider. After the connection, every hour it publishes its keep alive message. Every 4 hours it sends an optimal threshold based on external temperature, season and time day. The generic node receives a IP central unit with hour and minute to identify the emergency situation. There is a continued subscription for IP central unit and IP broker. Now we can see two scripts, one in which there is a communication with a central unit in co-op, there is RPC communication on the server co-op, then there is a script in which data are sent, relay state, humidity, power, and then the temperature is sent only when there is a change. The power and relay state is saved in JSON file.
Now the statistic web service send is keep alive, and we run the service scope for the communication with the central unit.
Okay, we can see the script for MQTT subscription for the external broker to receive the IP of the system broker. There is IP receiving. In fact, we can see the creation of JSON file with IP broker. There is the IP of the broker and the time of the publication. This is the script for publishing of the external broker of its IP, the IP of the central unit. And we have the two scripts that receive the keep alive and the data from the elements. The script below with a subscription to a specific topic save the keep alive JSON file from the all elements in a resource list, and we can see the resource list, the first element of the resource list, the broker. There is the updating of the resource list thanks to a specific topic. The script above, thanks to the use of wildcards and specific hierarchy of the data topics, receive all the information in JSON file from all the elements that publishes in MQTT, and we can see the resource list updated, the broker with its IP, the publication time used for updating of resource list and the cleaning of resource list. We can see the web service weather with the key entity type. We can see the resource of node, the simulated node, the Raspberry node with its topics of data publication, the time of publication, the entity type, and we can see the keep alive data received from the web service. Now we have received the data from the room node with a specific ID, and we have two types of file, info data and info statistic for statistic user present. We have the info data with specific elements, and we can see the data for statistic updating, the DP of the room node, and data, day, hour, and presence. We can see the info of other node, the Raspberry node, the presence, DP, the power state, the humidity, the relay state, and in the fundamental for communication and for saving data, because we have the title of JSON file related to the ID. And we can see the weather data with the optimal threshold, the outdoor temperature, and specific ID.
And now we show the Raspberry that detect the presence. We show send presence 1, and on the central unit in MQTT on a specific topic the value is received, and a callback save the presence and organize a weekly statistical file, JSON file, and today is a Sunday, so we can see the presence in the current time slot.
Okay, we modify the script that send the statistic on web server in co-op. Today is Sunday, and on Sunday we publish this data. We run the script, and we can see the statistics send for the actual active rooms and the interaction with the server co-op. In fact, once a week the central unit search for the resource list to know the current active rooms and send a co-op message. We can see the simulated room statistic week on the central unit. We can see the Raspberry file JSON with week statistical data, and we can see on the web server in co-op the interaction, and there are an update of simulated room node. In fact, we can see that on Sunday there is an update, and also there is the acknowledge message is sent to web server in co-op, and we can see the Raspberry JSON file. There is an update of number of week, and there is an update of Sunday on the JSON stat file on the web server statistical.
Every hour the statistic web service publish in MQTT the probability of presence for the next 2 hours, but only for the active rooms. In fact, we can see on the central unit there is the resource list with the node active. In this case we have 2 nodes active. On the central unit there is also the service scope, and on the left the statistical client asks in co-op with the transaction type confirmable and code get to know the active rooms, and it publishes the probability of presence only for these rooms. We can see now the JSON file saved on the central unit with the active node and the probability. And this is the interaction.
When in a single room there is a temperature variation, the last temperature value is published on a specific topic. The central unit do a subscription using hash wildcards to manage more rooms at the same time. The subscription triggers a callback to the decisional process about power and relay state in the room. For this decision are a co-op communication between central unit and statistic web server and node server.
On the first case, we have the temperature in threshold range and the central unit asks with client to the co-op server on node the current state of relay and power, and when the central unit receives this data, it switches off the relay with postcode co-op message. In fact, we can see the response on the room node. On the second case, we have the temperature out of range. The central unit asks to the server on node the current present with cop get code message. In this case, someone is inside in the room. After, there is another get request to know to now the current relay, and there is a put message for change the relay and the power. There is another change. The relay was already on, and there is a change of power with cop put message. And we can see the transaction on the room node.
In this third case, the temperature is out of range, but there is nobody inside, but the probability of presence is more than 85%. We can see on the room node the current state of relay and power. Now on the statistical server we set manually the value of probability of presence to 19%, and now the server co-op send the value of probability, and on the node the value is received, and as we can see the power is updated.
In the fourth case, we can see that the current active rooms, the probability is minus of 85%. In fact, we can see on the web service statistics that of the current day in time slot, the probability is minus 85%. We can see on the resource list these rooms, and we can find the probability of next 2 hours. There is a change of temperature, nobody inside in the room, no probability for actual hour, probability for the next 2 slot, update of current threshold, power and relay changed for energy saving.
In the last case, the temperature is out of range and the probability for the next 2 hours is very low. No temperature out of range, nobody inside, low probability, nobody expected.
The user have the possibility to consult the resource list. In fact, we have at right the web server in co-op that exposes the resource list, and the left the web client in co-op. We can see the resource list, and the user have the possibility to change the threshold. In fact, the user take the desired threshold, take the desired day in the week, take the init and end hour, and there is an interaction with web server in co-op on the central unit. We can see on the central unit the data updated, the JSON file updated with the user setting on day and hour desired. And when there is a comparison callback, we can find the setting user.
Moreover, the system allows the graphical visualization of the current state of temperature and relay thanks to freeboard.io, and the visualization of temperature trend thanks to ThinkSpeak.
The system also have an emergency tool that control the EPCU and EP broker published on JSON file. It periodically detects the hour of publication. If this is different from the current hour, the system emergency is activated. As we can see on the room note, the temperature is out of range and relay and power is set on. At the end, this is the system that is working.